Difference of squares. A squared minus b squared equals a plus b times a minus b. Now we use FOIL to check our answer. A minus b times a plus b. First, outer, inner, and last. A squared plus ab minus b squared. Cancel like terms, and we end with a squared minus b squared.
We can now use a geometric proof to prove the difference of squares. By calling one side A and one side B and creating a small square inside of our larger square with area b squared, the area of the black outlined area is a squared minus b squared. We now create a rectangle inside of the larger black square with one side length b and one side length a minus b. The side length of this new rectangle is a minus b, and the side length of our former square is also a minus b. We bring the rectangle around to the side of the former square. One of our side lengths is now a minus b, and the other side length is now a plus b. We can now see that the area is a plus b times a minus b, which is also equal to our original area of a squared minus b squared.
Here are some examples you can try at home. X squared minus 64 and a to the fourth minus 81. We know the square root of 64 is 8. And we also know that the square root of 81 is 9. We also find out that the square root of 9 is 3, which leads to our answer.
We can now check this problem. We use FOIL first to get x squared, outer to get plus 8x, inner to get minus 8x, and then last to get minus 64. We can now cancel the 8x's to get x squared minus 64. We can also check our next problem by using FOIL. By multiplying the first terms to get a squared, the outer terms to get 3a, the inner terms to get minus 3a, and the last terms to get minus 9, and multiplying by a squared plus 9, we can then cancel like terms to get a squared minus 9, a squared plus 9, which is again a difference of squares. We then FOIL, first, outer, inner, last, and cancel our 9a squareds to get our final answer, a to the fourth minus 81.
Some common mistakes when dealing with the difference of squares is wrongly recognizing a minus b times a minus b or a plus b times a plus b. These do not equal a squared plus b or a squared minus b. To check, we FOIL.
Ready for a challenge? Okay! Don't be afraid when you see big numbers or two variables. It's all the same, plus and minus. Here's the solution to this problem.